Hello everyone and welcome back to this episode of this intermediate inventory system, where we go over how to try and make a multiplayer inventory system and try and teach you some new stuff with Unreal Engines along the way. And let's begin. So I know we said we're going to start with blueprints, but I've actually found it easier to start with C++ to form the foundation of the components and then make blueprint children of them, and that's how you would normally do the workflow. So I've got a blueprint only project here, as you can probably see. If I go to my folder where I've kept it, there we are. I've got no source folder, there's no build.cs or anything like that. So how do we make a C++ project? Well, it's simple. We just go to Tools at the top, New C++ Class. You can be any class that you want, just go to Next, and make sure that it's in the project directory, and it will generate the source folder for you. You don't need to do any messing around with that. I'm going to make it public so it generates those folders as well, and let's create the class. We're not going to be making the inventory system in the source folder. We're going to be using a plugin to do that for us. So go to Edit, Plugins, and we're going to add. We're going to make our own plugin, I should say, sorry. And I'm just going to call mine inventory plugin. Yeah, beta version, why not? We'll untake that after it's completed. Author, agent arachnid, and let's create the plugin. And yeah, I'm building mine from the Unreal source code. That's why I've got the UE5 project there. I'm just going to close it down. You may have also noticed that I've got my own branch off of that. It's quite cool. It's quite cool having your own branch of the Unreal source engine. Unreal Engine source code, or however you say it. Okay, now that we've added the plugin, we should now get this opening up. Nice. You may have Visual Studio configured. This tutorial should work for both. So both Rider and Visual Studio. Let's go to Tools, New C++ Class, Actor Component, and we want to make this an inventory component base. This is just a naming convention that I use in most of my projects. The inventory component or objective component, interaction component, and then base at the end of it, just so it's easier to tell them apart. Go to the module that you want it to go into, and I'm going to choose mine to be the inventory plugin. And since it's a component, I'm going to put it in the components folder, and I'm going to make it public and create the class. So while that's adding, we're going to think about how we want this code to be structured. So if you're new to C++, this is the header file, and this is the C++ file. They get automatically generated when it'll create a new class for you. And you have a few different macros that you can use at your disposal in the C++ version of your components and classes. The first one is the uClass function, macro, sorry. And this just gives Unreal a bit more information about how you're going to be intending to use your class. I'll leave a site with all the list of all the uClass, uFunction, uProperty specifiers. That's what they're called, specifiers. But for this tutorial, you'll only need to know a few. The first one being that we want this to be blueprintable, which basically means that we can inherit from this C++ class in our blueprint, and we want it to be blueprint type as well, so we can actually use this type in blueprint as well. We probably also, let's make this abstract as well, because this basically means that we can't just create an inventory component base, we need to inherit from it, and I think this is what we'd want at this moment in time. We can always just remove this, but I think it's good to have it as a sort of base class rather than a class that's going to be used to be used, because we could have a inventory that's specifically for the player, we could have one that's specifically for chests, for quest stuff, for other characters. We could have different components for all of those that all do very slightly different things, but they all inherit from this. I could see that could be a very useful implementation. So let's go with this. We're going to get rid of the tick because we don't need it. If you can, don't use tick, and you can actually disable it in the constructor by setting primary component tick dot be can ever tick to false, because we don't want this component to be able to tick because it doesn't need it. So let's think back to our pseudocode that we did in the previous episode. What we need is a way to add, remove, and use items. So let's begin with just adding. We need a function that's no, not virtual. We don't need a virtual one. I'll explain why in a second, even though this is an abstract class. What we need is one that returns a boolean that is going to be called attempt item. In here we're going to have a U object pointer to an item and an int 32 for the quantity that we want to add. Now, how are we going to overwrite this in Blueprint or even in child classes? Because as we've mentioned, this is an abstract class. We need to make this something called a Blueprint native event. So let's type in U function, because this is similar to U class up here. This is the macro that's going to specify that this isn't just a normal C++ function, and we want this to be Blueprint native event down here. Not small caveat here, sorry. Blueprint implementable event is something different. Blueprint native event means that we can override this in Blueprint and in C++. And Blueprint implementable event basically means that we can only really override it in Blueprint, but we can call it in C++. What we also want this to be able to do is Blueprint authority only and Blueprint callable. And give it a category of inventory. There we are. Yeah. Okay. So let's quickly go through what this is doing. It's going to make sure that we can overwrite this in C++ and in Blueprint. We're going to make sure that we can only call this function when we're on the authority. So if we're on the listen server or dedicated server, if we're doing it in multiplayer, and if we're in single player, then it will just check if we're in standalone mode or not. And it'll do it. Usually in single player this does nothing, it just mainly does stuff when we're talking about stuff that has authority in clients. And Blueprint callable basically means that we can call it in blueprints. It's quite self-explanatory. So let's implement the rest of them. So attempt add item should only be called on the server, but the other two, attempt to use and attempt to remove, those could be called on clients. So let's do the other ones. But then again, attempting to add an item, I can see a scenario where we could try to do that on this client. So let's get rid of Blueprint authority only. Let's keep it protected. Let's actually make sure this is. Can we do protected? I think that's a meta specifier. So this is another group of specifiers called metadata specifiers, and we can say that this is only accessible within, well, the child classes of this C++ class. That's what protected means. It means that you can only access this property or behavior within child classes, which is different from private, because private basically means that only this class itself can view this property or behavior. Even child classes can't do that. Okay. So we're going to make sure this is overwritable in C++. We can call it in Blueprint, and it can only be called in child's. So what we need is an entry point into attempt to add the item, and this will give us the groundwork for the rest of the system. So we need a U function that is blueprint callable, and we're going to give it, yeah, pretty much that. We're going to return a boolean, and it's going to add an item, and we're going to come back down to protected here, and we're going to have a U function, and we're going to type in server and unreliable, and no, not with validation because we don't need that right now. And this is return void because this is something called an RPC, a remote procedure call. It will not return anything because it's basically making a call to the server from the client, and it, by design, it can't return anything, unfortunately. And we're going to call it server underscore add item. So what's the basic flow that we're going to go through here? We're going to call this function here from outside the class, so maybe say the interaction component, or maybe through a UI element or whatever. And we're going to check if we have the authority. If we have authority, then we're going to call this, and if we don't have authority, then we're going to call this, which will then loop back to here and call this again, which will then call this. And yeah, that's how it should work. Just trying to think if there's anything else that we should probably make sure is a blueprint native event. No, I don't think so. Let's do this then. You'll see why I made only that one function a blueprint native event in a second. I hope it works, but let's generate this stuff here. Okay, so this is our entry point, so let's mark this entry into adding an item from any source. Yeah. So if get owner, so getting the owner of this component, and we're going to check if that has authority, and if it does, then attempt add item, passing those in, and we're going to return this because remember we're returning a boolean. And if we are not on the authority, then we're going to call server add item with the right things there, and then we're going to return, let's return true if that, because we're making the attempt to call. Now server add item underneath here, we're just going to call add item, item and the quantity, and attempt add item implementation. We're just going to return true for now because we want to define this within the blueprint. So this won't work in multiplayer just yet. We've got one very vital thing we need to set is replicated by default to true, and that will essentially make sure that this component replicates. And yes, this looks like it should work. Let's make server add item protected as well, so it doesn't come up when we try to call it. And yeah, we can also, if you type / 3 times, it should pop up with a summary. I don't know why my browser's frozen. Give it a second. Okay. There we go. That's what should pop up. So we have a brief, say entry point adds an item in the inventory and performs an authority check to ensure that the that the execution takes place with authority. Okay, so the parameter item is going to be the item to be added, quantity, the quantity of the item to be added, and returns boolean, returns true if the item was successfully added, false otherwise. And if we now hover over this, we should now get a tooltip to say that information, essentially. And the cool thing is this should now pop up in Blueprint as well. So let's close down the editor because we altered a header file, and live coding is a bit of a pain in the ass with live coding. So let's run this, and we should now hopefully be able to generate a Blueprint child of this class and be able to do some fun stuff with it. And after this, all we need to do is repeat this for using and removing an item. And yeah, so just very quickly why I decided to go with unreliable over reliable. They basically use two different protocols. If you're familiar with networking in terms of the internet, it's kind of like the difference between, say, YouTube and Twitch. With YouTube, there's a bit of handshake going on. You have to acknowledge that all the bits and packets are in the right order and they've all arrived before you can confirm that the sending of the data was successful. With Twitch, it's just more about how much data you can physically get across. You know, it doesn't care if the packets are lost or missing or out of order. It just cares about sending them, and if it's received or not, then it doesn't really matter. The reason why I'm going for, you might say, why do you not use reliable all the time? Well, the reason is because it's a lot more heavy on the bandwidth. If you're running on a computer or on the network with not great internet, if every RPC you call is reliable, then it can clog up the bandwidth quite quickly, especially if you increase the number of players. And the reason why I didn't go with validation is because, at least not yet, the validation function, if that fails, it will actually disconnect the client. It's a way to handle trust and verification within the server, and well, I'm not very familiar with it. I only really learnt about that last month, and I still haven't got to grips with how it works. But the point I'm trying to get across is I'm not too bothered about that just yet. And if it comes up as a problem or as a bug later on, then I'll of course add it in. But premature optimization is not exactly ideal right now. So let's go back to here, and we should see that we're in our inventory plugin content. We can add a new folder. We could call this components, and create a blueprint class, all classes, and then type in inventory. Component base, select inventory component, and open that up, and we should now have a new function to override. Nice. And if we were to right click and go down here to find our inventory category, expand that out, we have add item and attempt add item, and as you can see here we have that information tooltip that we made. If you click on it and now hover over any of these, we should now get the same tooltip that we added. So that's how you do that. If I add item, yep. I'm actually going to go back to my C++. I'm going to add back in that blueprint authority only check to attempt add item. It's not going to change anything here because we haven't recompiled it. If we go to here, attempt add item. Now this is where we're going to do our work for now. We're going to get rid of this for now. Ideally, after this section where we implement all the stuff in Blueprint, we will go back and delete all this or reconnect it to use the parent function. We can easily add that back in just by right clicking on here and add that back in like that, but not quite yet. So let's think this through. We need a variable to say inventory slots, and we need a structure to keep hold of both the item and the amount in that slot. So let's make a new structure. I'm going to use the C++ one for now because it's just going to be easier to integrate it in later. So let's go to plugins, source, our inventory plugin, the public folder, and I'm just going to add a new file, call it libraries / f inventory slot.h. You may have to do some faffing around with Visual Studio if you're using that. So maybe go to File Explorer, go to plugins, and then just make a new folder, and then in that folder make a new text file or something in there. I'm just going to go with the quickest way for me personally, because this tutorial section is already 20 minutes long. I mean, this is a pretty good explanation of what Pragma once is doing. It's preprocessor director, tell, yeah. I don't know why it decided to add in a comment, but if you're not aware what Pragma once does, that's a pretty good explanation. I was actually about to explain what it did as well. Copilot is scary sometimes. What we need to include lastly is f inventory slot dot generated dot h. Now the reason is this is the code that's generated when you run Unreal's build tool or header tool. It's one of the two. And as you can see here, we've got it here as well. Every single object that inherits from U object or uses their macros needs to include this as well. Speaking of, this is how you define a struct with C++. You declare the uStruct macro, and we want this to be blueprint type, so we can use this in blueprint. And you have a struct, and you call it whatever you want. With the caveat being that it needs to have an F in front of it. That's just Unreal's reflection system and how it's built to deal with this sort of thing. So we want to put this F inventory slot, and we've got the generated body there. So we're going to add a new property to this. So we call it a U property. We want this to be edit anywhere, blueprint read write, and of course the category to be inventory, and CU object pointer. A pointer is, if you're not familiar, is just, well, a memory address that points to, that holds an object. So instead of the actual object itself, which is quite heavy, you point to the memory address where we can find that item, and that's considerably lighter, and we can just dereference it. It's fine later on. Let's actually make a default constructor as well, otherwise I'm fairly sure the compiler will complain at us sooner or later. Quantity is equal to 0. So we just made it default to an empty slot. So let's save this. Let's go back to our Unreal editor and make sure that we save this as well, if you haven't already, and let's rerun this. Now the reason why we're not just adding this as a T-array here is because I want to show you something else that you can do with Blueprint, which is very, very helpful. Also the reason why we're not making a Blueprint structure is because it's a pain to convert back into C++, because you've got two structs with the exact same name. Then Unreal gets quite confused as to which one it should use and where. And even if you name them exactly the same and have them have both their structures be exactly the same, it still won't work for you. So let's go to inventory slots and let's make our inventory slot structure, set to that, and let's set this to be an array. And as you can see, we can't do a set or tmap, and the reason is, I'm fairly sure it's because we haven't set something called, I think it's a get type hash or something to that effect. In order to have it as a key in a set or as a map, you need to define how Unreal should hash it. I'm not going to go into that in this tutorial, partly because, well, it's a bit complicated and I don't know off by memory. So we got an inventory slots array here. Let's just check if the item is valid. First of all, if you think back to our pseudocode from the last episode, if we know it's not valid, then we just return false. And we also do need to return something else as well, I've just remembered. If we go back to our C++, we also need to return int 32, and we need to return this by reference, remaining amount. So let's copy and paste this into all of these. Actually, no, we can't do that in the server function, can we? Damn. So we do it there and do it there, and we should be fine. You just need to add it in here as well, and quantity. There we are. Yes. Okay. Now, what have I just done? I've passed in a parameter by reference into these functions, and similarly, as server functions can't, or RPCs can't return anything, they also can't pass stuff in by reference, but they could maybe return by adding a const reference. I'm not sure, I'll check. No, can it return? Oh, apparently it can. I swear this threw up an error last time I saw it. There we go. And yeah, the remaining amount of the item that could not be added. So we're passing stuff in by reference. What that basically means is that we're passing a parameter in to the trying it out remaining amount. We're passing in a parameter, as you can see here, to say this is a reference. We're not just passing in the value of this parameter or this variable, we're passing in the variable itself. Yeah, replicated parameters cannot be passed by non-const reference. I thought it wouldn't work. I do apologize. Sometimes we should. Yeah. Int 32 meaning quantity. I got a bit confused there because, well, the squiggly red line went away, which I know doesn't mean it was gonna work. Yeah. So, as I was saying, what we're passing in is not the value of the variable, but rather the variable itself, which means that we can actually set this remaining amount in this function here to say remaining amount equals 0, and then when we exit out of this function, the value of this variable will actually be changed in the caller. So if we set this remaining amount to 0, then when we exit out of here, this remaining amount should be 0 as well when it's passed in. What does that mean in Blueprint? Well, if we open our inventory component back up, it means that we have an extra output that we can use. And this is also how you pass in multiple, this is also how you return multiple values in a blueprint as well, without needing a whole new struct that you can define. So, if we set remaining amount equal to the quantity that we passed in and return value to false, then perfect. Now what we need to do is add in a local variable. We're going to call this stack size. This is going to be an integer, and we're going to set this to, let's set this to 2 for now. Now, in one of the future episodes, we will be using an interface to get the stack size, but for now, we'll just set it to 2, just to see if we can test this properly. And what we're going to do is now iterate through our for each loop, but not before checking if the stack size is greater than 1. Because from the stack size we can infer if a item can be stacked, rather than using a whole new variable or boolean to say, yeah, we can stack this item. We can infer it, which in turn will make our item just a little bit smaller in memory. It's not a massive concern, it's just more neatness, but still something to keep in mind. So we're going to go from our branch here to see, yeah, we can stack the item, to then check if there's any instances of the item already in the inventory and if there's space for that item. So we're going to check if the item at each slot is equal to get item, the item that we're passing in. Okay. And now what we need to do is check if the quantity is less than less than the stack size as well. And we probably want to put this into an AND statement. So our array slots array, and then we're going to set array element and set the index equal over here, and the item we're going to make, and I'm going to use the item that's already at the slot, and the amount is going to be the min value of this amount plus overflow and the stack size. And the overflow after this point is going to be equal to a clamp integer between this and get quantity, and the min value and the value that we want here is going to be a plus between delta minus this value here and overflow here. Okay. Yes, this looks like it should work. And we're going to check if this is less than or equal to 0. And if it is, then we can return. There's no point in doing the rest of the iteration if there's no overflow left. So remaining amount, we'll just plug in overflow there and return value is true, or we could just plug that in there as well. So we're going to return out if we've ran out of stuff to add. Yes, so false value. What we're going to do here is we're going to do a while loop. Now these can be a little intimidating to some people because they can cause infinite loops very, very easily. They can crash your application, and if you have a load of errors or warnings stuck within here, then you can very quickly end up with a log file that's megabytes big, like hundreds of thousands of kilobytes large. So You have to be careful here. We need to have a condition that will eventually return false. So I'm going to have an AND function here to say if overflow is greater than 0, then keep on going. And we also need another function to say to get the free slot. I'm going to define that in C++ for now. So we're going to have another protected function. Say blueprint native event, blueprint pure this time, and again this is going to be blueprint protected. And this is going to return an integer, get free slot, and it's going to have const at the end because we're not changing the state of the object. We're going to generate the definition, and then in here we're just going to return -1 because in the C++ version we don't actually have an iterate over. We're going to save what we've done, so save back here and recompile it and run it. Okay, I may stop this because I've run into this before where it just stops working temporarily. I'm gonna get rid of this. So I've got rid of everything except for the config, the contents, plugins, and source files. And if I now right click on here, show more options and generate Visual Studio project files, it will then generate a fresh new project file for us. And just navigate down and open it up. And this should hopefully resolve the error that we were just facing there. There we go, it's starting the build off. That took longer than expected. Yeah, I'll come back once it's finished. Okay, there we go, perfect. Let's open our inventory component back up and let's override our new getReslot function. So what we want to do here is get our inventory slots for each loop and just break this, and we want to check is valid. No, sorry, wrong one. We want the blueprint pure one, this one. And the quantity is greater than 0. So we want to check both of these, but we want to check them in a NAND boolean. So what this basically does is an AND function and then applies a NOT function after it's completed. So what we're checking if is essentially, okay, if it's valid and the amount is greater than 0, then return false. If the item is not valid, but the item is, then return true. If greater than 0 is true, or vice versa. So this is basically perfect for what we want. We want it to only return true if either the item is invalid or the quantity is less than 0. Either way, I think it's perfectly fine to overwrite this slot, i.e. it's free. So let's return this. And then if it's true, return the index in the for loop, and if it's completed and there's still nothing there, then return -1. And go back to here and then just drag this out. And we want to check if this is greater than or equal to 0. I'll put that into the end. And in the while loop itself, we'll get our inventory slots and set array element, or rather set get a copy. And no, not copying. Let's just go back to set array element. This is going to be easier for a lot of people, including myself. What we also want to do is cache this, because sometimes it can be a bit weird. So free slot, set it up here, and just again verify that this is greater than -1, or rather is a valid index in here. This should actually be here, not that. 2 seconds. Because we don't want to enter here if this is not a valid index, because it could return into an infinite loop. I don't know. And then if it's true, then we set the array element with the index being our free slot over here. The item we're going to make with the item that we passed in, and the quantity is going to be a simplified version of all this. It's literally just going to be the max integer between our current overflow and our stack size. And then all we need to do with our overflow is just set it to a clamped between max of the quantity that we passed in, the value being our overflow minus this quantity here. And then when we complete out of here, we're going to return the remaining amount, which is going to be our overflow, and our return value, which is just going to be if this is less than or equal to 0. And perfect. That is our adding item to the inventory check function completed. If we go back to our event graph, we add item. If we actually add this in now, what I did before with the blueprint authority only, it gives it this icon here. That's how you can tell if it's authority only or just a normal node. It also has a nice tooltip added to it to say this is authority only. It's quite nice, I like it. Compile this, and now let's actually try to use it. Begin play, this runs on both server and the client, so if we go from here and add item, and if we choose, let's go with the first one as a character, and let's try to add a quantity of, let's say, 5. Then what this will do is, this is my prediction, this is what I'm intending to happen. When this is called on the server, it will just add the item straight away. When it's called on the client, then it will do the same thing, but it will call the RPC to the server to add items. So in actuality, we should get 10 items added. That is what I'm predicting to happen. But in order for that to happen properly, we need to set up our inventory slots to replicate. So we'll click on our inventory slots variable here, go down to replication, and we'll do rep notify. And this generates a function here. This is going to be called on the client when the variable replicates. If we go from here, we'll do a for each, because we want to iterate over here. And we're going to do something called a print text, not a print string, a print text. And here we're going to do a format text to say slot index has quantity of item. So if we press enter, we get a few what are called wildcards. They can be any type. And as you can see, they only appear when we give them in the text itself the curly braces like this. So if we add the index, and if we then break this and give the item and the quantity, what this should now do is when we receive the change in inventory as a client, we should now get this. If we now go to our first person controller that we want to use, I'm using the first person character template. If we now add this in, so if we type it in inventory, we only get 1. Now think back to the, earlier on when we were talking about the abstract classes. This is kind of what it means. It means that even though it's blueprintable and a blueprint type, we can't actually use it as a component to add. We can only use it as a component to inherit from, which is quite nice. It makes it nice and simple. We double check component replicates here and go to class defaults and just double check that it replicates, which it doesn't in this case, but we need it to. So if you now go to here, go to the 3 dots at the top, go to net mode, and we want to play as a client. Clear the log, and let's pray that this. Oh wait, no, there's one last thing we need to do. I'm sorry. We actually need to make it so that the inventory has slots to begin with. I forgot that I needed to do that. So let's just add a few here. Let's add in, let's go with 10 slots so we have plenty of space. Of course, we'll add it so that it will dynamically add these slots in later. This is just for testing. So let's play this. And let's scroll up to see if we get anything. This is odd. Why aren't we getting anything? Let's look at the controller. It's the inventory component, and we can't see the inventory. Why not? Let's do that. And let's go to our event graph. Let's add a breakpoint here. Let's go to our blueprint version and let's add one here, just to see if we are actually entering this properly. So let's play it. So we are adding it on the server, as you can see here. So it's valid. Yeah. Stack size. Yep. This is what I'm expecting to happen. And then it just exits out. We'll have to double check the while later. So add item, as you can see on the client. If we press play, we should now jump to the server. Yes, nice, so that RPC is working. We have a look here. Number is 10. Let's add a breakpoint here. And one here, and one here. Let's add a print text. Let's add one here as well, just to see if we're ever making it past these branches. And let's actually go back to the event graph and do a print text here, just so we can see if what this is returning out of. Add item be success. Remaining items. So there we go. So we should now print out if we were successful or not. So now if you press play, add item. So we're never making it here or here. So where are we returning? So we're getting past there. Oh, oh, that was a bit of a blunder there. Yeah, make sure that the for each loop, when you complete it, we're doing the while loop. Okay, that should now fix it. Let's remove all these. That was such a stupid mistake on my part. Can't believe I did that. Okay, let's do this. There we go. So, client 0, slot 0 has 5 of this item. Add item, return true, remaining item 0. Slot 1 has 5 of this item. So if we go back to our inventory component, we're adding 5, and we have 10 in these two slots. Perfect. That's exactly what we expect and what we want. Unless you remember the stack sizes too. So it shouldn't be giving you more than 2 in each slot. So why is that happening? Well, let's take a look. The overflow is overflow minus this quantity here. And if we have it here, then I used the wrong one. It's supposed to be the min value of these two, not the max. Maths. So we now do it. Bottom. There we go. Slot has 2, 2, 1, 2, 2, 2, 2, 2. There we go. Yeah. I hope you guys enjoyed this. This is an hour-long episode. Oh my god. I hope you guys enjoyed this. In the next episode, we'll be going over the same steps, but for removing and using items, which should be a lot smoother and a lot easier to do. Now, you might be wondering why we're doing all of this, the for each followed by the while loop, and the reason is we kind of want to prioritize stacking the items over filling the inventory with items. Because if in this example, it's quite simple to say that we're filling it from the bottom or the top down, like from left to right, or however you want to visualize it. But if you had like half a stack at the beginning and then an empty stack at the end, like with only one item, then you'd kind of want to fill those stacks up first before filling up empty slots, which is kind of why we're doing this search through the inventory first before then trying to fill up the inventory. Yeah, that's kind of the design decision behind that. In the next episode, as I mentioned, we'll be going over removing and using items, and as I've mentioned, it'll hopefully be a lot easier and simpler. We'll be using the same structure as well of going into C++, and if I get this up, and just adding to this, so we've got more to add items. I'm just going to copy this down, remove, use. We're going to use two different types of using and removing. We're going to remove an item just in general from the inventory and removing it at a particular index, and the same thing for using an item as well. Both will have their uses. Yeah, hopefully you guys found this tutorial helpful at the very least. Maybe not entertaining, but at least helpful. And I hope to see you guys in the next episode. Bye.